area of region bounded by two or more curves or graphs. That is area under and between curves. So let's proceed here. There are a number of applications of integral calculus, right? So the determination of, for instance, the determination of areas, means and root mean square values, volumes, centroids, and even second moment of area and radius of gyrations are all included, right? So for this tutorial, we are only going to look at area under and between curves. And here we go, right? So let's see something. Let's see this diagram over here. For this diagram, we can say that the total area, the total shaded area, is equal to integral of a to b of f of x dx minus integral of b to c of f of x dx plus integral of c to d f of x dx. So looking at this diagram, you can see that there is one function which is y equal to f of x. That is the function. And that function, because it's a polynomial function with a power of 3, you can see how it has been curving along the x-axis, right? It cut the x-axis 1, 2, 3. See, the power of 3. So we have a one function which is y equal to f of x, but that function curves above and below the x-axis, right? And in that case, when they ask you to find the area or the total shaded area, right? What you need to do is that it's the same as the definite integral, or similar to the definite integral that we did, area antiderivative as an area. But in this case, because some of the portion, the shaded portion, it's below the x-axis and some are above the x-axis, we are going to consider a different strategy in solving such problem. So in this case, the shaded portion above the x-axis is being considered as positive, and then the shaded portion below the x-axis is being considered as negative. So as you can see over here, this is from A to B. This is the limit from A to B. You can see it's above the x-axis, so it is what? Positive. So from B to C, you can see that the area is below the x-axis, and since the area is below the x-axis, you can see that it is what? Negative. And then the last but not the least is C to D. You can see that the shaded portion is above the x-axis, and therefore it's being considered as positive. So that is how we find an area bounded by two curves, or areas under and between curves. So you will be given a question, and the question, you need to sketch the graph out of the question, and sketching the graph out of the question will also help you find whatever you want to find. So there are also some instances where you will be given two graphs, and the two graphs, two functions. The two functions, after plotting them, you can see that maybe, for example, maybe function 1 will pass here and function 2 will pass maybe here. Let's say this. So in this case, we consider the upper one as the positive and the lower one as the negative. So let's take note of it. So always we consider the upper one as the positive and the lower one as negative. So assuming that the upper function is f of x and then the lower function is g of x, what we need to do here is that when we want to evaluate, let's assume that here has a limit of a and a limit here to b. So if we want to evaluate this function, what we need to do is to find the definite integral between the limit of a to b, and then the overall function that we are going to deal with is becoming of what? F of x, because f of x here is the upper one, as you can see here, and the lower one here becomes minus g of x. So let's take note of it. So these two functions, we evaluate the limits, which is a to b. Therefore, if we do that, we'll be able to find the area between these two curves. The same thing can also be applied to functions like this. Sometimes you can see functions like this, and then this, and they ask you to find the area of the shaded portion. So the area of the shaded portion, they can ask you to either this place or this place. When from this place, this is an upper one, it's going to be positive. This will also be an upper one, it's going to be positive, but this is a downward, going to be what? Negative. So let's take note of it. I'll be solving some couple of examples with you. So at the end of the day, you'll be able to distinguish the various strategies on how you can solve questions concerning areas under and between curves. So thank you for watching, and see you in my next tutorial. And my next tutorial, we are going to talk about how you'll be able to draw the graphs given the function in the question before you can proceed to find the areas under and between those particular functions. Okay.